Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. Good morning! Welcome back to Stories from Space. I'm your host, Matt Williams, and today I want to delve deeper into the Fermi paradox. As we explored in a previous episode, the Fermi paradox is named after famed physicist Enrico Fermi, who in 1950 sat down to lunch with his colleagues and asked a famous question, one that would launch 1,000 proposed resolutions, and that was, where is everybody? Or more precisely, if life is ubiquitous in the universe, if it's very, very common, and we have every reason to suspect that it would be, then why is it that whenever we look out at the cosmos, we are presented with the great silence? Why is there no evidence of intelligent life out there? As I said, this question has inspired a lot of proposed resolutions over the years. And today I want to deal with the earliest and simplest explanation, which is known as the Hart-Tipler Conjecture. And according to the Hart-Tipler Conjecture, the answer to this question is there are no aliens out there. There's no advanced intelligence, otherwise we would have seen it by now. There would be signs that would be unmistakably indicative of intelligent life and technological activity, and since we're not seeing that, they don't exist. Now, this theory takes its name from Michael Hart and Frank Tipler, two astrophysicists who proposed this in a series of papers that were published between 1975 and the early 1980s. And Michael Hart in particular is a very controversial figure because, in addition to being a scientist, he was also a white nationalist and separationist. And the way he framed this theory of his and how he framed Fermi's entire premise, this is how the Fermi paradox has come to be debated ever since, for better or for worse. And their theory of both Hart and Tipler came down to the idea that if an intelligent species had emerged in the past, they would have had more than enough time to evolve advanced technology and would have begun exploring the universe using von Neumann probes. And von Neumann probes refers to an idea put forth by John von Neumann for universal assemblers, or machines that could replicate themselves endlessly and indefinitely. And this idea has been applied over the years to space exploration and it's been recommended as a means of space exploration for us. And of course, it's been used in the context of SETI, the search for extraterrestrial intelligence, by saying that if we are contemplating this idea ourselves, then chances are an advanced species out there that's had a jump start on us would have already created it. And realistically, it's just a very, very good way to explore the universe there, send out probes that can consume base matter and produce more themselves, and that at a certain point, they would have explored all the regions of the galaxy, they would have converted so much matter that you would not be able to miss their presence. So, as I said, Hart is the one who framed the Fermi paradox as we know it today. He said that if life were ubiquitous in the universe, it would have colonized at least our galaxy by now, and since we see no evidence of that, that must be taken as an indication that intelligent life does not exist beyond Earth. And by his own calculations, he determined that an advanced species would only need 650,000 years to explore and colonize the entire galaxy using these self-replicated probes. So given the age of the universe, roughly 14 billion years, given that humanity's only been around for the last 4.5 billion, any species that came before us, because astronomers are of the opinion that, because astrobiologists, they're of the opinion that life has been possible in our universe for at least 13 billion years. So by Hart's own estimates, any advanced civilization would have colonized our galaxy a long time ago. They would have visited Earth. They probably would have colonized here too. And this is not entirely without merit because, according to the legend of Fermi's conversation with his colleagues, he, after raising the issue of why hasn't Earth been visited yet, they started doing a bunch of little napkin calculations on how long it would take an advanced species with advanced propulsion to travel from one star system to the next to explore the extent of the galaxy. And just based on their napkin math, they came to the conclusion that this is something that would have happened several times by now. But of course, this whole premise is laden with some massive assumptions. So Frank Tipler came along years later, and when he refined the calculations, he said that it would take more like 300 million years for a species to expand. So a longer time frame, but a very similar conclusion. And to quote his paper, he said, "What one needs is a self-reproducing universal constructor, which is a machine capable of making any device given the construction materials and a construction program. In particular, it is capable of making a copy of itself. Von Neumann has shown that such a machine is theoretically possible. As the copies of the space probe were made, they would be launched at the stars nearest the target star. When these probes reached these stars, the process would be repeated and so on until the probes had covered all the stars of the galaxy." So basically, Tipler, much like Hart, he was making a Occam's razor-based argument. Given the lack of evidence for ETIs, the simplest explanation is that there's none out there. But Carl Sagan came along, and in 1983, he and a colleague of his named William Newman, they published a paper that came to be nicknamed Sagan's Response, and its actual title was The Solipsist Approach to Extraterrestrial Intelligence. And whereas Tipler had argued Occam's razor, Sagan and Newman were arguing the Copernican principle, which basically states that what we see around us here, Earth, life on Earth, our solar system, and so forth, that it is indicative, or it's representative of the universe as a whole. And it is so named after Copernicus because it was he and Galileo, through the creation of the heliocentric model, they demonstrated that Earth was not special, that the other planets of our solar system are planets much like our own, that we all revolve around the sun rather than everything in the solar system revolving around Earth. And so by extension, astronomers have kept this principle in mind. And so for well over a century now, they have been looking outwards into at the other planets of the solar system and other star systems within our galaxy, other galaxies in the universe, with the intent and with the hope of finding conditions and life, much as we know it here, elsewhere. So Sagan and Newman, they said it far more beautifully, and I'm quoting from their paper right now. "One of the distinctions and triumphs of the advance of science has been the deprovincialization of our worldview. In the 16th century, there were battles over whether the Earth is at the center of the solar system. In the 17th century, about whether the stars are other suns. In the 19th century, about whether the Earth is much older than real or mythical human history. In the 18th and to 20th centuries, about whether the spiral nebula are other galaxies, something like the Milky Way, and about whether the sun is at the center of the Milky Way, and in the 19th and 20th centuries about whether human beings have arisen or evolved as an integral part of the biological world, and whether there are privileged dynamical frames of reference." Now, what he is saying throughout this is that every time science had taught humanity that they were not special, that they were the product of evolution that gave rise to all the other life forms on the planet, that the planet is incredibly old and humanity is merely at the very tip of geological history, that our solar system is young compared to the rest of the universe, and that, yes, our solar system is representative of others, and our galaxy itself is similar to others that are out there. So he goes on to say, they go on to say, "The latest issue in the long series of controversies on our place in the universe properly concerns the existence of extraterrestrial intelligence. And, of course, Carl Sagan is forced to concede that there is no apparent evidence of intelligent life out there. But to this, Sagan and Newman, they offer the famous and often repeated line, but absence of evidence is not evidence of absence. And they then went on to challenge the entire basis of Hart and Tipler's own conclusions by saying that, well, it is so full of assumptions, the timelines involved, the rate of replication of probes, the notion that an alien intelligence would send out such probes, that they would multiply ad infinitum, and how this would ultimately, if you examine the math, it would mean that such probes would consume all matter in our galaxy there long before humanity even emerged. So the idea that anyone would just send out probes like that without any kind of safeguards or limitations, it is naive. It is very, very linear and fatalistic. But ultimately, Sagan and Newman's point was that the fact that we haven't heard from extraterrestrial intelligence yet can be explained any number of ways. Simply saying that it's proof that there's nothing out there is solipsism, which is the idea that nothing beyond the self can be known. We don't see evidence for something out there, therefore we're the only thing that exists. I have spoken to several people who find Tipler's argument very, very convincing, very compelling, but I definitely side with Sagan on this one. It's that the possibilities are endless, and the lack of evidence on this, the fact that SETI research is so very data poor, that supports no conclusions. The lack of evidence is basically ignorance, and we have not yet had the challenge to even search our own, and we have not yet had the opportunity to really fully explore our own cosmic backyard, really, and to say nothing of the universe. We haven't even begun to scratch the surface. So, yeah, this brought me to another very interesting conversation I had with another distinguished scientist by the name of Gregory Matloff. And yes, he's been around for some time. He has been highly influential when it comes to, in theory and actual research efforts for interstellar space travel, for astrobiology. He's a member of the British Interplanetary Society and the Academy of Astronautics. And yeah, he consults with NASA to this day. So he wrote a very interesting paper, and I got a chance to interview him about it. And it was titled Von Neumann Probes, Rational Propulsion, Interstellar Transfer Timing. And when I questioned him on the subject of the Hart-Tipler Conjecture, because I figured I knew the answer to this and what he would have to say, and he responded exactly as I thought he would. He found the idea ridiculous, really, and he was not afraid to say so. And what he had to say itself was very convincing, which was that the solar system is huge and mostly unexplored, and probes, von Neumann probes, would be, in all likelihood, very small. And they could be anywhere, for that matter. They could be in craters of the moon. They could be lurking in the asteroid belt and the Kuiper belt. We have cataloged and studied so few of the objects in these belts. We've observed many larger ones, many smaller ones, but missions to actually investigate any of them and name them to fully indicate that we can confirm these are in fact rocks and not bits of debris, not something that would raise a whole lot of alarms there as far as, oh my God, this could be alien technologies. Yes, he said there are 100 million objects in the Kuiper belt alone, and we have examined only 2, one of which was very anomalous in its shape. And he's absolutely right. That was MU-69, or Arrokoth. And that was encountered by the New Horizons probe back in 2019 after it flew by Pluto. This was the first object it encountered. And it was named a contact binary because it looked like 2 objects that had come together and stayed that way, but rather than being sort of semi-spherical, rounded, or just irregular in shape, they were flattened. And these are icy bodies made up with all manner of other materials, dirty snow, basically. And yes, the New Horizons team, they said basically it looks like a snowman, and that's Alan Stern gave it that nickname. So, of course, if we're going to start, if we discuss anything specific, like von Neumann probes and how they behave, we're working within a theoretical framework. We're working with what we know about propulsion, about interstellar travel. And what Matloff had to say was very, very well-timed, and there's no coincidence there. 2017, the arrival of Oumuamua in our solar system. It led to a rather controversial theory being argued by Professor Abraham Loeb, who said that it could very well be, or could very well have been, a defunct spacecraft that was drifting through our solar system, that was equipped with some kind of solar sail technology, and that's why it accelerated as it was leaving our system, and in a way that was not consistent with a comet or anything else. If it had been a natural object, it surely wouldn't have behaved the way that we observed. And while he was not arguing, oh yeah, it was definitely an alien object, he was suggesting this, and though controversial, it stimulated a very, very robust argument about what this object could have been and the only conclusions that could be drawn. And Loeb said this himself in his original paper and several times since. The only thing we know for certain was that this was an interstellar object. It's the first of its kind that we've ever detected, and that alone indicates that there must be a lot more of them out there. And so from that, Loeb himself and several other researchers, they conducted computations, and they said that, well, if we assume various rates of interstellar objects entering our system and then leaving, we can say with high confidence that many of them would stay. And in the history of our solar system, that means that quite literally thousands, tens of thousands of objects have arrived in our system, and a statistically significant number would have stayed behind. They would have been captured by Jupiter's gravity or by some other planet there, and they would have become part of the many, many populations of asteroids and objects throughout the solar system. So what was really exciting about that was, and Matloff echoed it there, right? There could be objects in our asteroid belt or around Jupiter in the Kuiper belt. By sending out rapid transit low-cost missions to explore objects in our own solar system, interstellar objects that were captured over time, then there is, in fact, a minute, but nevertheless, a chance that we could wind up discovering a defunct alien probe. And Fermi's paradox would be resolved right then and there. We know for a fact intelligent life exists elsewhere in the universe because somebody manufactured this. It was sent here. We can't say with any confidence if they're alive or dead anymore, but they did exist. We know that much. And it is worth noting that since the Office of the Director of National Intelligence declassified all these materials related to UFOs, and it was colloquially termed the UFO report, and this information began being released in 2020, and a report was released last year. Since that time, NASA has created a task force to investigate what is now being called unidentified aerial phenomenon, and Professor Loeb, to bring him up once again, he too launched a project to investigate all this information called the Galileo Project through Harvard University and the their Center for Astrophysics. So really, the issue of von Neumann probes, whether or not alien life exists out there, whether extraterrestrial intelligence exists out there, and the whole question of the Fermi paradox, especially where the notion that if we ever found evidence of intelligent life, that it wouldn't be the species themselves saying hello, it would most likely be their technology. We would confirm their existence by encountering something they left behind or something they sent out a very long time ago. This has all come back around with tremendous force in recent years. It is a very, very popular topic once again. It's a very relevant topic once again, and especially when you consider that in addition to these new research efforts that they're public, they're not private and led by military or intelligence circles anymore. They're being pursued by scientists out in the open and talked about, and findings are being produced. And in the coming years, there are many, many exciting missions that are planned that are going to start looking for life beyond Earth in other ways. We are going to be sending missions to Europa, Ganymede, and Titan and Enceladus to look for evidence of life there, most likely in microbial form. We have robotic missions that are going to explore interstellar objects and look for evidence of technology there. We also have efforts that are going to be looking through all the archival data and any new data on UAPs, unidentified aerial phenomenon, to try and find proof that what we're seeing here is in fact something of extraterrestrial origin. And last, there's efforts through exoplanet studies, thanks to James Webb and next generation telescopes that are going to be working with time-honored venerable telescopes like Hubble and ground-based telescopes. They're going to be looking for signs of life and technosignatures, signs of technological activity in distant star systems. And there's also renewed SETI efforts, traditional SETI efforts, which is listening with radio telescopes for signs of transmissions, trying to tease out any possible conversations in the cosmos. And all these efforts they're currently happening, they're building up speed, or they will be happening very soon. So the search for extraterrestrial intelligence is entering a whole new phase. And there's no guarantee that any of these efforts that they'll find anything definitive or concrete. In fact, there's no guarantees that humanity will ever find evidence of intelligent life beyond Earth, beyond our solar system, ever. We may very well, as a species, go to our graves having never, ever answered that question. Are we alone? But as I've definitely said before, if there's evidence out there to be found, we are going to be in a very good position to find it. And as time goes on, with further improvements in our instruments and our data analysis, we're only going to get better at it. So if there is evidence to be found, we're likely to find it before long. Now, what we do with that information is, of course, entirely up to us. How we choose to react to it is entirely up to us. But when it comes down to Fermi's paradox and that grand old question, are we alone or are we not? Are we special or are we indicative of the norm? It only needs to be solved once, right? One piece of evidence, one discovery, one signal that can be shown to be communication rather than just background static. You find one line of evidence that cannot be explained by natural phenomenon that is demonstrably artificial in origin, and the key word there is demonstrable, right? Carl Sagan had said extraordinary claims require extraordinary evidence, but all you need is one piece of evidence, and Fermi's paradox is solved, and we know for a fact that intelligent life does in fact arise in the universe, that it has arisen in places other than Earth, and of course I'm referring not just to humanity, but nature does seem to favor the creation of intelligence in many, many, many different forms and across many different species and parts of the animal kingdom. Humanity is not unique even here, really. But the bottom line is that the search for extraterrestrial intelligence and astrobiology, search for life in general out there in the cosmos, it's not going to be data poor forever. So this is my main concern with the Hart-Tipler conjecture, in that it took what was, certainly at the time and even now, an extremely data poor field of research and attempted to draw some very, very fatalistic final conclusions from it. And hopefully we'll be able to prove it wrong in just a short while. In the meantime, I hope to dedicate more episodes to this subject, and I definitely want to get into more of the proposed resolutions. And these fall into many different camps, which can sort of be crudely organized into the aliens do not exist, they're out there, but they're ignoring us, they're hiding from us, they are keeping us blind, we don't know how to look, we haven't looked long enough, and we may have already seen them, but we wouldn't recognize them as such. There are many, many very interesting takes on this, and they are the subject not of wild speculation, and certainly not just science fiction, but of very, very serious academic research. And given enough time, I believe we could cover quite a few of them and really do this subject justice. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.